Welcome back to KQ's channel. I'm Madam Chan here. Today we are going to look at chapter 7, which is the graphs of motion. In BM, it is called graph gerakan. In this chapter, you are going to learn two subtopics. The first subtopic is the distance time graph, and then the second one is speed time graph. So today we are going to look at distance time graph first. I'm going to show you on how to look at the distance time graph. There are examples of distance time graph like this. Okay, whereby the y-axis indicate the distance, and then the x-axis or the horizontal axis indicate the time. Okay, this is also another distance time graph. Okay, the y-axis or the vertical axis represent the distance. It can be in meter, kilometer, and so on. And then the x-axis represent the time. Okay, if it is distance time over time, meaning that this line is speed, right? So the gradient of the graph, this part here, it represents the rate of change in distance with the respect of time. Okay, changes in distance with the respect of time. That is speed. This one also you have learned in Form 2. So speed is distance over time. This is the distance over time graph that we have. Now we look at the next one. Today we are going to learn how to draw a distance time graph based on, first, we are going to learn to draw based on distance timetable. And then the second one, we are going to draw based on the equation that represent the relationship between distance and time. Now we look at the first one here. Example 1. Azree wants to be a track cyclist and hope to make Malaysia well known in the world like Arizulhasni Azreen, our national track cycling champion. The table below shows the distance and the time taken by Azreen during the training. So this is the table here, showing the time 0, 30, 60, 90, 120, and then the distance 0, 10, 20, 30, 40. The question, they ask you to draw a distance time graph based on the graph above. So to draw a distance time graph, first you need to make sure you have to plan a proper scale. Okay, choose a suitable scale to represent the distance and also time. So over here, remember the vertical graph, the vertical axis or the y-axis represent the distance and the horizontal axis represent the time. Okay, after that we have to plot the graph. Okay, so for the time the x-axis it is 0, 30, 60, 90, and 120, right? So the distance is this. Make sure you represent the scale properly, and then we are going to plot the graph. To plot the graph, you just remember on the x and y coordinate that we have learned. So time and distance 0, 0, it is this part here, the position, and then 30, 10, this is 30, 10 is over here. After that we have 60, 20, so 60, 20 is right here. Then we have 90, 30, 90, 30, and 120, 40 is right here. After that, you just join the points plotted using ruler to obtain the distance time graph. So make sure you use ruler. I cannot use ruler over here. Join correctly. Okay, until this point. Now we look at the second example here. Mr. Darren drove his car for a distance of 360 km from Kuala Lumpur to Alor in 2 hours to visit his mother. The distance S kilometer that Mr. Selva traveled in T hours is given by the equation S equal to 40t. So they ask you to draw a distance time graph to represent Mr. Darren's journey from Kuala Lumpur to Alor. Okay, before you draw the distance time graph, make sure the first thing that you have to get ready or you have to prepare is the table of value. Okay, so the table of value I've prepared over here is like this, from 0 to 1, 2, 3, because it mentioned that in 2 hours visit, so make sure you have the 2 over here. Okay, using the equation S equal to 40t, so if the time is 0, okay, it will be 40 times 0, so we will get distance is 0. If it is 1, 40 times 1, 40, 40 times 2, 80, and 40 times 3, 120. That is how you get your table of value. Then we try to figure out how to draw the graph. Remember, you have to plan the proper scale. So the scale is uniform over here, so we just label 1, 2, 3 on the horizontal line. And then for distance is 0, 40, 80, 120. So this part will be 40. And then this is 80. This is 120. Then we can plot the graph already. 0 and 0 is the origin. After that we have 1 to 40. then we have 2 to 80, and then 3 to 120. So again, you have to join the point plotted with ruler. Okay, now we look at the next example. Jaswinder Singh takes part in 8-kilometer cross-country event organized by the school during National Sports Day. The relationship between distance from the finishing line and the time of the run is S equal to 8 minus 1 over 5t, where S is the distance in kilometer and t is the time in minutes. Draw a distance time graph to represent Jaswinder Singh's run for the duration of 0 to 40, in between 0 to 40. So make sure when you draw your table of value, it includes 0 and 40. So I've got it ready already. So when the time is 0, the distance is 8, because from the equation here, when t is 0, 1 over 5 times t is 0, so 8 minus 0, we get 8. When the time is 40, then it will be 0. The distance will be 0. Okay? So get ready on how to draw the distance time graph. So over here, we have time in minutes for the horizontal axis and distance in kilometer for the vertical axis. So I'll get ready these two. Get ready these two, and then you can draw the line. So for example, I'm going to draw the line here, and this. Start with 0. Make sure you use ruler because I don't have ruler provided here. Then you can make sure your scale is uniform. So the scale that we have over here is 0 to 40. 0 to 40, so I can make in between maybe a 10, a range of 10 in different. So you can see I can have 10, 20, 30, 40. And then this part will be, let me see how many we can make. Make sure it is uniform. So we need to make sure we have 8. So we can start with 2, 4, 6, 8. Then we can plot already. With time 0, the distance is 8. So the coordinate is here. And then with the minute of 40, the distance is 0. So the graph is a negative graph, or the negative gradient graph. Okay, then it is done. So we continue. Now, from this chapter, you have to know how to interpret the distance time graph, because later on you will have to answer questions based on the graph. So we have a distance time graph over here. Okay, whereby the y-axis indicate the distance and then the time in second. Then the time here is t, the distance is s. Okay, we are going to see how are we going to interpret all the distance time graph here. This diagram, it shows a motion from O to C for a distance of s meter in a period of t second. Okay, now we look at the line OA first. Line OA, if the slope is going up, meaning that it's a positive gradient. And then the gradient of OA here, it represents the speed of motion. So the motion is at a uniform speed, meaning that the speed is all the same all the while on the point on the line here. Okay, and then motion for a distance of s1 meters in a period of t1 second, represented by this line. Now we look at the second line, AB here. AB is a straight line here. It means 0 gradient, no gradient at all, meaning that there's no change in distance. So it is stationary. The motion stops. Okay, and then the period is from t1 to t2 seconds. So if you want to find out the time, it will be t2 minus t1. Then we look at the third line here, line BC. Same, is a positive gradient. The motion continues to C. So to interpret the whole graph from O to C, it means the motion from S meter, motion of S meter in a period of t second. Okay, now we look at the next example. Again, this is a distance time graph, showing that the distance here is represented by S and then the time represented by T. So this is a motion showing from O to R, passing through P and Q. O to P is a positive gradient, so it is a motion for a distance of s meter in a period of t1 second. Then if you look at the second line here, P to Q is zero gradient. There's no change in distance, which means it is stationary. And then it's stationary for a period to T2 minus T1 second. And then for the last one here, from Q to R, this is negative gradient. You have to remember this part here. Negative gradient meaning that it shows the object moved back to the original place or move in the opposite direction. Okay, it doesn't mean the speed is slowing down. There's no slowing down, just that it is in negative to indicate you go back to the original place. Okay, so from O to R here, it is a motion of 2 meters, 2s meter. Why 2s? Because going through is 1s, going back is another s. So the total is 2s, okay, in a period of t second here. Okay, now we look at the example. Example 4, the distance time graph shows the motion of a car and a tour bus. Graph OA represents the motion of a car from Puchong to Melaka. So O to A, from Puchong to Melaka. So I indicate over here so that you can understand better later on. So from Puchong meaning that start from here, Puchong, which is zero distance, to Melaka, meaning that the total distance from Puchong to Melaka is 150 kilometers. Okay, now the second here, graph BC represents the motion of a tour bus from Melaka to Puchong. So BC, the green colored line here, represent from Melaka, go back to Puchong. Determine the difference in speed in kilometer per hour of the two vehicles. Sorry, typing here, per hour is on top. Okay, so first we are going to find the speed of the car first, from O to A. To find the speed of the car, we have to use the vertical difference, which is 150 minus 0 over 2 minus 0, because this is a line, right? 150 minus 0. So you will get 75 kilometers per hour. Okay, then to find out the next one, it's the same thing. I show you the example here. To get the gradient, it changes in y. Like just now, we use 150 minus 0 over the changes in x, which is 2 minus 1. Okay, same thing. If you want to find the gradient of the bus here, it will be the last or the ending here, which means it is 0 minus 150 over 3 minus 0. So you will have a negative 50 kilometers per hour. It doesn't mean it's slowing down of negative. The negative here, remember just now I've told you, it indicates the tour bus or the car moving in the opposite direction. Okay, so we just change it to positive, which means which to represent the speed of the tour bus, 50 kilometers per hour. Okay, therefore we can answer the question already. They ask you to determine the different meanings that the higher speed minus the lower speed. So 75 minus 50, it is equal to 25 kilometers per hour. Okay, now look at example 5 here. The distance time graph shows the motion of a car for a period of 4.5 hours. So we can see here 4.5 hours. Determine the duration when the car is stationary. So I have already given all the answer over here. We look through slowly. You don't go through very fast. So when we were asked to find the duration when the car is stationary meaning that the motion is none. Okay, meaning that there's no speed at all. So the duration will be 3 hours minus 2 hours. That is 1 hour. Okay, and then you have to determine the speed in kilometer per hour of the car in the first hour. So if you look at the first hour is on this line, right? This one, right? But we don't have the reading on this part here on the left on how much is the distance. But we know that the speed is uniform all the while on this line. So we can use the distance over here, 150 minus 0 over 2 minus 0 to represent the speed of the car in the first hour, this part. So 150 minus 0 over 2 minus 0, the answer is 75 kilometers per hour. Okay, for B, this is B. Describe the motion of the car for the last 90 minutes. Where is the last 90 minutes? This is 1 hour 60 minutes, right? 120, this is 180, this is plus 60 again, 240, so this is 270. So the last 90 minutes will be, this is 60 minutes plus 30, so 90 minutes is this part, meaning that we look at this graph here. Okay, describe the motion. So we have to find the speed. The speed is the vertical distance over the horizontal distance. So it is 270 minus 150 over 4.5 minus 3. So we will have 80 km per hour. Therefore, to describe, you got to describe how much is the distance, how much is the time taken, and also the speed. 3 important things. Okay, so the car travel for 120 km with a speed of 80 km per hour in the last 90 minutes. Sorry, in the last 90 minutes here. Okay, make sure you always mention the distance, the speed, and also the time. Okay, now we look at the next example here. Sohana cycles to the post office to send Hari Raya Aidilfitri greeting cards to her close friends. The distance time graph shows Sahana's journey from her house to the post office and back. A, determine the total distance in kilometer for Sahana's whole journey. So this is from her house to the post office. After that, she goes back. Then they ask you to find the distance of the whole journey, meaning that from her house to the post office is 2 km. Go back again will be the same, so 2 plus 2 is equal to 4 km. Second, find the value of t here. If Sahana cycles with a speed of 8 km per hour to the post office, so if you want to find the time, remember you have learned the formula of distance, time, and speed. So to get the time, it is distance over speed. Therefore, the distance is 2 over the speed given is 8. So 2 divided by 8, you will have 0.25 hour. Then you convert it to minute by multiplying 60, so you will have 15 minutes. Therefore, if you want to find the t, you have to start from 9:20 plus another 15 minutes over here. So the answer will be 9:35. Okay, then we look at B here. Describe Sahana's journey from the post office back to her house. So if you want to describe her journey, first you have to find the rate of change. Okay, the rate of change in distance is 0 minus 2 here. And then this part here will be 1010 minus 950, but then we have to divide by 60 because this is 24-hour system, right? If 1010 minus 950, so you will have 20 minutes. And then when you divide by 60, here you will have negative 2 divided by the answer given. So you will have 6 km per hour. Okay, the negative 6 meaning that she goes back. Therefore, to describe, Sahana cycle for a distance of 2 km in 20 minutes with a speed of 6 km per hour. Okay. Then we look at example 7 here. Zabeda wants to visit her friend in Muar. Here, this is Muar. The distance time graph shows her journey by car from Segamat to Muar. Okay, Segamat to Muar, passing through Tangkak. A, calculate the average speed in km per hour of Zabeda's journey from Segamat to Muar. So you have learned on how to find the average speed already. The formula for average speed is total distance over total time. So total distance is 80, the time is 1.5. 80 divided by 1.5, you have 53 and 1/3 km per hour. Then B, if the rate of change in distance of the car from Segamat to Tangkak, here, is 50 km per hour, calculate the distance in kilometer between Tangkak and Muar. Here, Tangkak and Muar, you have to find the distance. So before that, we have to find the value of S over here by you're given the speed already, right? Therefore, to get the distance, DST, remember, distance is equal to average speed times total time. So you're given 50, 50 times 1 hour here. Okay, 0 to 1 hour. So you will have 50 km over here. Therefore, you can answer the question already. The journey from Tangkak to Muar will be 80 minus 50, which is 30 km. Okay, then we look at C here. Describe the motion of the car from Segamat to Muar. From Segamat to Muar, the whole journey. So if you were asked to describe, you have to describe the distance, the speed, and the time. Okay, so I give you the description here. The car moved for a distance of 80 km in 1.5 hour with an average speed of 53 and 1/3 kilometer per hour. Okay, now we look at example 8. The incomplete distance time graph shows Mr. Tan's journey from Seremban to Lumut. So it is incomplete, meaning that it's not finished here. Mr. Tan stops at Rawang for lunch, here, Rawang, and a short break before he continues his journey to Lumut. Okay, A, if the average speed of Mr. Tan's car from Seremban to Rawang is 66 to 30 km per hour, calculate the distance in kilometer between Seremban and Rawang. So you were given the average speed. If you want to calculate the distance is equal to speed times time. So it will be 66 to 30 multiplied by the time here, it is 1.5. So you will have 100 kilometer. Okay, that's the distance between Seremban and Rawang. So this part is 100 kilometer. B, the distance between Seremban and Lumut is 300 km. From Seremban to Lumut, somewhere here, is 300 km. And Mr. Tan drive at an average speed of 80 km per hour to reach Lumut from Rawang. So Rawang, from Rawang here to Lumut. Complete the distance time graph to represent Mr. Tan's whole journey. So over here, we know that the whole journey is 300 km, meaning that this is 100, right? 300 minus 100, the difference or the distance between Rawang and Lumut is another 200 km. Okay, after that, we are going to find the time taken. So time is equal to distance over speed, which is 200, over the speed given, which is 80 km per hour. We will have 2.5 hours. Okay, and then they ask you to complete the given distance time graph, so we just have to add on up to another 2.5 hours, and then this one to 300 km. Okay, so it will be like this. 2.5 plus 2.5 is 5 hours. This one indicate 300. So this part is the Lumut. Okay, that is done already for the graph. Then we look at the next example here, example 9. The distance time graph shows the journey of two cars between Kuala Lipis and Cameron Highlands. Graph PBQ, this one, graph PBQ, the green color one, represents Encik Manaf's journey together with his family from Cameron Highland to Kuala Lipis to attend his cousin's wedding. So from Cameron Highland to Kuala Lipis, I can indicate like this so that you can understand better. This is Cameron Highland, this is Kuala Lipis. Okay. Graph OABC, the red colored, represent the journey of Encik Raven's family from Kuala Lipis to Cameron Highlands. So here it represents Kuala Lipis, this part here, Kuala Lipis to Cameron Highlands. Okay. Now they ask you to find the rates of change in the distance of OA and B. Oh, sorry. They give you the rates of change in the distance for OA and BC are the same. O to A, B to C are the same. Calculate the value of T. So in order for you to do that, we know that the rate is distance over time, right? So you just make equation like this. 65 minus 0 over 52 minus 0 is equal to 135 minus 65 over T minus 77. So what you do is you just cross multiply this part here, cross multiply. So you will have T minus 77 is equal to 70 times 52 over 65, because you want to find the T, right? Then just calculate, then you will get the T as 133 here, 133. Now we look at B, the average speed of Encik Manaf's journey. Which one is Encik Manaf? The green color one, right? So you're given the average speed is 72 km per hour. Calculate the difference in time in minutes for the two journey to reach their respective destination. So to calculate the difference of time, we know that the total time taken for Encik Raven's family is equal to 133, right? So for Encik Manaf's family will be 135, the distance 135 over 72 km per hour as given over here, and you can get the time already, which is 112.5. You need to make sure the hour that you get, you multiply by 60 so that you get the time in minutes, because the time indicated over here is minutes. Therefore, to calculate the difference, it will be the total of 133 minus 112.5, it is 20.5 minutes. Okay, so that's all for the first subtopic today. I'll see you again in the next lesson for the second subtopic.